When China's Lunar New Year Gala kicked off this year, over 700 million viewers tuned in, expecting the usual traditional dances, folk songs, maybe some acrobatics. What they got was something no one was prepared for. As the stage lights shifted, dozens of Unitree G1 humanoid robots emerged from the darkness. Each one was styled after ancient Chinese warriors. Some were modeled after the legendary Monkey King from Chinese folklore, complete with ornate headgear and staff weapons. The fusion of cutting-edge robotics with centuries-old cultural identity was deliberate. These weren't generic machines. They were symbols. And then they started moving. Not stiff, mechanical gestures. Fluid kung fu sequences in perfect unison. Strikes, spins, weapon flourishes, defensive stances, all synchronized to the millisecond across every robot on stage. The precision wasn't human-like. It was beyond human-like. No performer miscounted a beat. No movement lagged. Every motion was mathematically identical across the entire group. The audience sat somewhere between amazement and unease. But here's what most viewers completely missed. This wasn't entertainment. It was a technological declaration. And to understand why it matters, you need to see what happened in Russia just weeks before. In Moscow, a company publicly unveiled their humanoid robot, a doll. The plan was simple. Walk from backstage to center stage, wave at the audience, and demonstrate basic mobility. For the first few steps, everything looked fine. A doll moved forward, raised its hand, and appeared stable. Then its stabilization system failed. The body tilted forward. It overcorrected, lost its center of gravity, and crashed face first into the stage. Staff scrambled to intervene, but the video was already racing across social media. This wasn't just embarrassing. It was scientifically revealing. Walking is something humans master by age 2, yet it remains one of the hardest unsolved challenges in robotics. Balancing a tall, top-heavy frame on two narrow contact points, while compensating for constant microshifts in weight, requires thousands of calculations every second. Russia's robot couldn't handle a flat, controlled stage. China's robots executed synchronized weapon choreography without a single stumble. That contrast alone tells you who's leading this race. So let's break down what these machines can actually do. The DRO-2 from Deep Robotics stands 175 centimeters tall, weighs 65 kilograms, roughly the build of an average adult, and was built not for stages, but for harsh, unpredictable environments. It moves at 4 meters per second. For reference, the average human jogs at about 2.5 to 3, meaning this robot outruns most people. It climbs 20-degree slopes, carries 20 kilograms across both arms, and crosses mud, loose rock, and shallow water without breaking stride. Push it mid-step, and it catches itself instantly. The same kind of disturbance rejection Boston Dynamics pioneered with Atlas, but a fraction of the cost. What truly caught the research community's attention, though, wasn't the specs. It was the Tai Chi. During a public demo, DRO-2 performed slow, deliberate Tai Chi movements. This wasn't cultural decoration, it was precision engineering. Tai Chi trains the robot's joint actuators to make continuous micro-adjustments while shifting weight gradually between positions. The results are measurable: improved core stability, smoother posture transitions, and dramatically lower energy consumption. Fast, jerky motions burn battery life. Controlled flowing sequences teach the system to accomplish the same tasks using minimal power, extending operational time by a significant margin. DRO-2 wasn't practicing martial arts, it was learning efficiency. And that is a genuine breakthrough disguised as an ancient tradition. Now here's where things get truly remarkable. Unitree took their G1 robot and trained it to play table tennis. Not pre-programmed swings against the pitching machine, actual real-time rallies against human opponents. Consider what that demands. In competitive play, a table tennis ball can travel upward of 20 meters per second. The robot must track the ball mid-flight, predict its landing point, calculate the optimal racket angle and swing speed, coordinate its arm, shift its torso for balance, and reposition its legs for the next shot, all within roughly 200 milliseconds. That's faster than a human blink. The AI runs on 2 layers. A high-level strategic planner reads the ball's trajectory and selects the best return, placement, spin, power. A low-level reinforcement learning controller then converts that decision into precise motor commands distributed across the entire body. The upper layer decides what to do. The lower layer figures out how. What makes this more than a party trick is transferability. The ability to track a fast-moving object and execute a coordinated full-body response in under a fifth of a second isn't just useful in sports. That same architecture could drive obstacle avoidance, emergency navigation, or real-time decision-making in chaotic, unpredictable environments. Table tennis is the benchmark. Real-time adaptability under pressure is the actual capability being built. But breakthroughs by individual robots don't reshape industries. Scale does, and this might be the most important development most people scrolled right past. Deep Robotics released footage of a fully operational factory line manufacturing quadrupede robot dogs. Not hand-built prototypes, but standardized commercial units moving through assembly stations, tested, packaged, and ready to ship. Rows of identical finished units stood in formation like products in a fulfillment center. When any technology jumps from hand-built lab prototypes to factory production, it crosses an irreversible threshold. Unit costs plummet. Availability expands. Adoption timelines compress from decades into years. Each unit ships equipped with LiDAR for 3D environmental mapping, vision systems for terrain and object recognition, and onboard AI that adjusts balance in real time. They climb stairs, navigate cluttered industrial corridors, and handle rough outdoor terrain, all autonomously, no human operator required. 5 years ago, a single robot dog was a multi-million-dollar research artifact confined to a handful of elite labs. Today, they are a product line with a shipping department. The question has permanently shifted from, can we build them, to where do we deploy them first? And here's what most tech coverage won't tell you. The most immediate real-world impact won't come from robot soldiers. It will come from robot workers. The Quantu from X Square is a wheel-based humanoid designed for indoor environments, offices, warehouses, hotels, logistics hubs. Standing roughly 1.65 meters tall with 62 degrees of freedom, it navigates corridors, opens doors, operates elevators, handles packages, and adjusts grip pressure automatically. Firm for heavy boxes, gentle for fragile items. The open arm one adds 7 degrees of freedom manipulation to the picture. It grasps, rotates, and positions objects with near-human dexterity, adapts its grip force to each object's size and weight in real time, and operates tools like wrenches and switches. These aren't combat machines. They are tireless workers built for repetitive, precision-critical tasks that are expensive or impractical for humans to sustain around the clock. Far less cinematic than a robot army, but far more likely to change your daily life within the next 10 years. So let's answer the question we opened with honestly. Are robots about to surpass humans? Not tomorrow. The Idal failure proves that reliable bipedal locomotion remains unsolved for many teams worldwide. DRO2's Tai Chi training shows that basic energy efficiency is still being learned and refined. The G1's table tennis ability is impressive but limited to one controlled task. What has changed, and changed fast, is the trajectory. 5 years ago, most humanoid robots toppled on flat surfaces. Today, they play real-time sports, perform synchronized martial arts with weapons, and roll off assembly lines as commercial products. The gap between laboratory experiment and deployable machine has collapsed faster than virtually anyone in the field predicted. Those robots on the Chinese stage weren't performing for applause. They were demonstrating capabilities that will reshape logistics, manufacturing, disaster response, and healthcare in the years ahead. They weren't built to replace us. They were built to work beside us. And the timeline for that future just got dramatically shorter than anyone expected. If you want tech analysis that separates what's real from what's hype, no sensationalism, just what's actually happening, hit subscribe. We track these developments every single week, and what's coming next will make this video look like ancient history.